This project began as a study in how to get maximum altitude for minimum cost. One way to do this is to lift off with a powerful high thrust motor as stage 1 and then pile on many long burning motors for subsequent stages. This particular rocket test is not attempting high altitude but is simply a small scale test of massive multistaging. This is a successful launch of a 9-stage rocket. The first stage is an Estes E12 black powder motor. The remaining 8 stages are all C6 black powder motors made by Southern Cross Rocketry. The total rocket height is 586 millimeters. Total rocket weight is 284 grams. The upper 8 stages are inside a rack rocket. The nose cone is 3D printed and can be found on the Thingiverse website. The vertical rods are carbon fibre tubes with an OD of 5mm and ID of 4mm. Each upper stage motor is glued in a thin cardboard sleeve that overlaps the next stage. Fins are 3.2 cm long, which is longer than they need to be. These fins are carbon fibre 1 inch high and 0.8mm thick. The same carbon fibre section is used to create a square cage around the rods at the level of the upper fins. A wrapping of carbon fibre above the top fins gives extra tensile strength. On the first stage, 5mm OD carbon fibre tubes are split in half and slotted to hold the fins. The launch lugs are not shown here in the correct final configuration. Launch is from police paddocks in Melbourne. Launch is vertical in a very strong wind, so the rocket ends up flying a long distance into the wind. On stage 7 start, the distance is 3.4 kilometres as measured using the speed of sound between the sight of the puff and the sound of it. The 9th stage separation could still be heard and was far above the horizon. For the next launch, I'll reduce fin height to reduce wind sensitivity and aim the launch downwind in the hope of getting a 2.8 kilometre apogee. This shows an open rocket simulation.